Okay, lots of ideas for the most terrifying ride, right? The Screaming Eagle. Basically, this is a pendulum ride, so the period of it should equal 2 pi square root of L over G, where L is the length of the pendulum. Length, is that how you spell length? In meters, right? And then this is, of course, the acceleration of gravity in meters per second squared, so that would be about 9.8, right? And then the length would, of course, be from there to, and then you have to decide where the sort of the center of mass of this whole thing is, right? Probably the center of mass is really close to there, right? Okay. You can measure the length. I'll put another video up on the Screaming Eagle about measuring the length from a diagram, because if you look in the media and data folder for the Screaming Eagle, there's a schematic that I downloaded from the manufacturer's website. It's actually called a afterburner by them, but we call it the Screaming Eagle. So this is one thing to do. Another thing you can do about the period is that the period is not supposed to depend on how far it swings, right? It should be the same if it swings a little bit or a lot, right? But that's not strictly true. If it's swinging all the way up to here, it's quite possible that the period is longer, right? So that would be another thing to do, is to make a graph of what's the period versus the angle that it swings through, right? It actually should go kind of like about the same, and then kind of goes up like that, okay? But it might not be strictly a simple pendulum because there's a motor driving it, right? So that's an interesting thing, right? So that's one thing you can do, right? At the bottom here, okay, if this thing didn't rotate, right, at the bottom there we could do a very simple thing, right? We could figure out this height, right? And I don't know how successful this would be, right? But we could figure out, let's say it swings to like here or something like that, right? We could figure out this height, right? And we can say mgh is equal to 1/2 mv squared. So here's another idea, right? Okay, so figure out whatever that height is there. Okay, notice that the m cancels, so we don't need to figure out how much the mass of that is, right? You could figure out the velocity of this, right? Okay, and how do you figure out that height? Well, use the diagram. You can measure the diagram that I give you in the media and data folder. So I'll post another video about that, right? Okay, then you can figure out the velocity. Now, of course, this is now a vertical circle, so at this point right here, okay, your acceleration would be v squared divided by r, and r would, of course, be this radius from here to here, right? That would be your acceleration, and you should measure 9.8 plus that acceleration at the bottom, right? Now, I don't know, because this thing rotates, so it generates way more than that because of the spinning and the craziness like that, right? Okay, but anyway, that if it were a pure swinging ship sort of thing, you could do that. And maybe you guys are smarter than me, and you can figure out how to relate that to the chaotic data, right? Okay, let's just look at the data for this thing, right? If you go to Oaks Park and you look at the Screaming Eagle, right, and you go into the data folder. If you go down here, oh, by the way, these are the diagrams where you can get good measurements from it, right? But let's look at the vertical data. So I'm doing a control click, save link as. I'm going to save it in there. There it is, and I'm just going to open it. Don't save. Same file. Okay, there we go, right? Here's another thing that you can do. There are two different types of periodicities that are going on. In other words, two different things that have frequency. One of them is the swinging of the pendulum, and that has its own period, right? Okay, and then there's also the rotation of it. So if you select this part here, there's a thing you can do. You can insert an additional graph. There's something called a fast Fourier transform. And what this does is it tells you the frequency of these things. I'm going to make this be 1 hertz, because 1 hertz would be 1 swing a second, and God help us if it does that, right? Okay, so here, if you look at this, 0.2 hertz would mean that it's swinging once every 5 seconds. That's the frequency of it, right? 0.1 hertz would be once every 10 seconds. If you look at this, there's something that's going on. A primary thing is going on here at a little more than 0.2, between 0.2 and 0.3 hertz, right? So 1 divided by that is the period of that. That might be this major swinging of it, right? And then one of these also might be the rotation, which happens a little faster. So that's sort of interesting, right? You can analyze and look at the periodicity of this thing, right? Remember that this is frequency, so 1 divided by this will give you the time it takes to do whatever it is that you're measuring. So anyway, those are just some ideas. Okay, check this out. I mean, this is just truly amazing to me, right? It's approaching 50 meters per second squared, which is about 5 Gs. And then I love this. Look at this. It generates negative Gs, right? This is not only, I mean, 0 would be like you're free falling. You fall at times faster than you could free fall. If you dropped a rock during this part here, the rock would go up, right? Anyway, you gotta love it, right?